Nethermill Primary is a very rural school. It's a school with only 2 classes, primary 1 to 4 and primary 5 to 7. We have 36 children. I'm the teaching head of the school. Problem solving as regards the older class is primarily my responsibility.
In Scotland, problem solving has been a formal part of the 5 to 14 maths curriculum since 1991.
Right, warm-up time, mental maths. So all we want is any way of making 180. Neil?
100 add 80.
Teachers are finding that problem solving can play an important part in the development of children's social skills and attitudes to work.
Well done, Scott. OK, could I have the 4 people who are coming with me to do some problem solving this morning down to the hall, please? OK? Right, have a quick browse over that, please, if you don't mind, first of all.
The polygon problem, involving geometry and algebra, is a challenging one for this group of 10 to 12-year-olds.
So the first thing we need to be sure of is what a polygon is.
Where all the sides are the same size and all the angles are the same degrees.
Yep. So an interior angle is that part there on the inside. An exterior angle, you've got to do this. What you do is you take one of the sides and you extend it, and that angle there on the other side of the interior angle is the exterior angle. Okay, do you understand that?
Yeah.
Now, we've got our key strategies in front of us that we've used before. I don't want you to get too bogged down in which strategy you're definitely going to use at the beginning. But what we will do is at the end we'll talk about the strategies that you ended up using. Off you go. With any problem-solving activity, there's a touch of the unknown about it, and I think that's where part of the fun comes from, as well as part of the fear. But what this problem really requires is for our small group to be able to work effectively together.
The first step for the group is to measure accurately the interior and exterior angles of the different polygons Mark has prepared.
Need to extend it. Right. Out one. Exterior. 160. Yeah, 60. Somehow I don't think that's right.
Neither do I.
Just put it down and see what the inside one comes to.
Yeah. Check it.
61. That comes up to 177. Yeah, that's not right.
That's not right.
No. Because it has still got to add up 180. It's a regular triangle, so the inside one's always got to be 60, isn't it?
Yeah.
So that will be 60.
So it must be the outside one that's wrong. It's the outside one that's wrong.
Yeah. Measure it again then. There, that's at 120.
That's not like it.
Okay, so should we do another shape?
Yeah, do the full
Try that one now.
Try.
The angles of a pentagon are particularly tricky to measure accurately because they're not round numbers.
There, that's the
Extend one.
It's there. 70. And I've got 110.
70. Yeah, that's right then. Yeah, that's right. 110.
They've measured the angles incorrectly, which will cause a problem later.
What about the rectangle? Very easy, isn't it?
That'd be 19.
I could just make it.
The kids know that the interior of a square is 90 degrees and therefore the exterior would therefore be 90 degrees. I was interested to see that they still wanted to measure that.
Put it that right up there and then put a mark at 20 there.
The penny finally drops.
It's kind of obvious.
It's going to be 90 degrees.
Right, do you want to try the other one now?
Okay.
Then the hexagon.
Just extend that one. Yeah. Extend it.
I think these will be 120.
That's kind of off 60 actually.
Right, 60.
Right, 60. So everyone should be
120. Yeah, it's the opposite of a triangle.
About 120.
Yeah, 120. Yeah. What's the connection between the number of sides and the exterior angle? Wait, that's got 6 sides and that's 60.
Yeah.
And then that doesn't really work out for that one.
I know, because this one's got
5 sides.
5 sides.
5, and it's 70, and that one's got 3, and that's 60. That's double that, that's the same as that.
I don't think that's got anything really to do with it.
The children have gathered all their information but can't work out how to move forward.
120.
That's just
120.
that's just for the triangle and the
10. That doesn't make sense, that one. This
I know.
one and that.
that one doesn't make
Where's
sense.
the rectangle?
Well, I
There,
don't-
90 and
maybe-
90.
Well, maybe it doesn't.
In the square.
Well,
I
maybe.
didn't expect them to be quite as stuck with taking the information they got and coming up with the idea of putting it in a table, and that required a bit of input from myself to make that leap.
We might have to do it another way.
Right, and that's
Yeah,
you're thinking that way.
if it doesn't make sense, then maybe we're doing it wrong.
Well, I'm going to give you a slight clue in that you've actually picked out the shape that is incorrect. Your measurements are incorrect there. But what you're saying is important here. What you're saying is that it doesn't make sense to you. Now that's a problem, isn't it? Hence, problem solving. So the next part is, how do you get unstuck? You have lots of information. You've created a lot of information here. What are you going to do with that information to try and make sense of it? Now, if you look down your list of strategies that we have there, which of these is about organising your information?
Draw a diagram of
Yeah.
I'll look for a pattern.
Look for a pattern. What else?
an organised list of table. You draw like something like that, right, and you put a number of sides here, and you
Yeah.
put the degrees, and then you can kind of work out like,
Then do it. Then do it. Okay?
just draw like a square basically on the back of this paper.
I don't know.
Mark's clue about organising their information gives the children fresh impetus.
Why don't you write 3 lines down there?
Number of sides. Put a number of sides in, like,
Yeah. Number of sides, angle,
Oh, wait,
interior
wait,
and
no, wait.
exterior.
There we go.
Do the
4.
triangle first.
3 then.
3.
Then put the square.
Exterior is 120.
120.
And the
Then 60.
60.
Then do the square. He's got.
Yeah, 4 and then the
So 4 is
90 and 90.
We need to do this one, I think, because it's the one that's in between.
Yeah.
Put that one down.
That's 6.
That's
I'll leave a gap
Yeah.
so it will.
6. 60 and 20. 120.
60.
No, no, because that there's
Yeah.
yeah.
And 120.
There. So then
Right,
you've got
so
Then we've got.
Draw this again.
I think we should actually draw it again.
Yeah.
Like draw it again because I
Yeah,
think
'cause
we've
it's
got the
getting a wee
angles
bit
wrong.
messy.
Yeah.
is it 115 maybe the thingy one?
Can I just give you a quick clue with that one, folks? If you don't mind, Scott. This one, the pentagon is much more difficult to do. Its angles are 72 and 108, so they don't come round to nice round numbers. But you can add that information to your table, and now you're looking for the relationship, Murray, yeah?
There's a pattern there. That's a
Yeah.
30. That's a 30 and that's a 30.
Yeah.
I know, but
That's
what's
bad,
this one
okay.
fit in?
No, but if it didn't, if it
I mean,
didn't
you're
fit-
adding 18.
No.
Yeah, 18.
Oh,
and
yeah,
And then you're adding 12.
Then 12.
But we've got to figure out how it matches with the sides.
Yeah.
So
I know that's what I was stuck.
we're stuck on this part here because
But it
we
made
can't
sense if
find
I was
that.
times 1
Okay.
out of 20.
Right, I understand why you're stuck. Your information's good. The way you've organised it is also very good. What you should maybe start thinking about is, what's the relationship between these and the complete angle, the complete turn? Think about the 360 degrees in relation to the number of sides and the exterior angle and the interior angles.
Well, there we've done 3 times 120.
What if you take
Three.
the pattern?
3 times what, Scott? What Scott
times-
said was important.
3 times 120 is 360.
Okay.
And 4 times 90 is 360.
360, yeah.
And 6 times.
60 is 360. Does this one here, the 5 and the 72, does that create 360?
Yeah.
Yeah.
Right, so that's really important. That's your pattern. That's the pattern. That's your relationship between the number of sides
And the exterior.
and the exterior angle. But now, if you think about the algebra work that we've done before, where we've got, can you have the number of sides and you've got the exterior angle? Can you find a way of writing that down? I'll get your piece of paper.
Total turn divided by number of sides
No.
equals
Do the algebra thing
exterior.
where you just.
Murray instantly comes up with the formula linking the number of sides and the exterior angle.
No, you can just use 360 for that
Why?
because the angle of full turn doesn't change.
Yeah, it doesn't.
Right, 360 divided by
N sides
equals.
equals exterior angle. EX angle, just put.
Okay, EX and angle.
There's got to be an easier way to write.
That's a
Yeah.
bit.
Yeah, but you're absolutely correct with your solution, because that is the solution. But I think you're correct, Murray. What you just said, there has got to be an easier way to write this. So if you had exterior, which letter could you choose to represent exterior angle?
E. Z.
So there you go, you could put E in, couldn't you? And do you need to have sides next to the letter N?
Just put say S next to like against ball letters.
Yes, you could do that, or just N. So you could have, as you said, you could have 360 divided by N equals the exterior angle. That's really important, right? And that is you solved the first part of the problem. An old-fashioned 3-penny piece was a regular 12-sided polygon. And it says, using what you've discovered, can you calculate its interior and exterior angles? Well, I want you to find out. It's 12-sided, regular polygon. What would its exterior angle be?
30.
How do you know?
Because
What is it, 12
360 divided by 12 would be 30.
30.
Yeah.
So, there it is. There's your 3-penny piece. 12-sided, regular polygon.
Yeah, it will be 30.
That means its exterior angle, each of the exterior angles is 30. Can you create a formula that enables you to be able to figure out what its interior angle would be?
You have to add it.
Would it be
Take away from 180.
I'm going to leave. Well, you discuss that with the group. Say that again.
I think what you do for the 12-penny coin, you've got 12 sides. No, 3-penny, and you've got 12 sides, that's 30. Then take that away from 180, which is 150, which would give you the interior.
Yeah.
360 divided by 12
Oh, yeah, sorry.
Equals, don't put the bracket.
If you can involve them in the kind of eureka moment of problem solving, where they actually get to achieve something, where they actually get to find something out, then that's partly where the joy of maths comes from.
Equals 150. Yeah.
Round of applause. Yeah, I'm impressed. I'm impressed, yes. Okay.
A little later, there's a reporting back session.
Well, we drew all the shapes out and then we measured their angles and then did the exterior angles.
We started looking for a pattern and then we made an organised table to see if any of the patterns would fit with all the angles that we've got.
Encouraging children to explain how they arrived at their solution is an important part of the problem-solving programme in Scotland.
How did you know to use 180 in that part of the formula?
Because half a turn is 180, and when you get a line going off of the shape, then you've always got 180.
Right, okay. How did the table help you?
It helps organise your thoughts and keep track of the angles and degrees.
Right. What about the way that you worked as a group?
If everybody's good at one thing, it doesn't work, and if everybody is good at like a different thing, then it's better. You work better together.
That's right. What about the challenge of finding out something?
It makes you quite happy if you find it out and then get it right, because you think you've done the impossible because you couldn't have done it like a week before.
The second programme will be a discussion about this problem-solving session.